Hey everyone, this is Vamsi from coderefer.com and welcome back to another tutorial on Leetcode 30-day challenge, day 24, that is jump game. So let's get started. Given an array of non-negative integers, you are initially positioned at a first index of the array. Each element in the array represents your maximum jump length at that position. Determine if you are able to reach the last index. So input is given as 2, 3, 1, 1, 4. So output is like true or false. Let's quickly explain using an example what this question is expecting us to solve. So this is our first example which was given in the problem. A list with 2, 3, 1, 1, 4 is given with 2 as in 0th position. We have to check whether we can traverse till 4. So this is our 0th position. So now our index is at 0th position, that is 2. So at max we can jump 2 positions from 0th index. So let's jump either to first position or second position. Let us assume first we jump to position 1. So here again the element is 3. So from one position we can jump to either 2 or either 3 or either 4. So this is shown using arrow marks here. From 3 I can directly approach to 4, which is my last index. Hence we'll return true. Let us take second example of our problem. Here 3, 2, 1, 0, 4 is the array given. At 0th position we have 3, means we can traverse up to 3 positions to the right. So we'll first traverse minimum distance of 1 and we reach 2. Again from 2 we can traverse at most 2 positions. So we'll take minimum path and we'll traverse till 1. We have reached second position to 1 and now we will again traverse through minimum position 1. So now we have reached 0. So this is a dead end. So we cannot traverse from 3 till last element. So now we'll travel with precision of 2. So we reach it from 3 to 1. Again 1, we can traverse at most of 1 element. So we have reached again 0. So it is also a dead end. Now we will traverse from 3 to 0 with precision of 3. At most we can reach 0. Again it is also a dead end. So in any of these scenarios we cannot reach this 4. Hence we are not able to traverse from 0th index to last index. Hence we will return false. If we think about the approach to this problem, the easiest way we can think is like by jumping to every possible single position and jump from that position to every possible position. So again if we are stuck, then we again backtrack using recursion. So this is the basic simple approach we can follow to tackle this problem. So let us explain this approach. So we will be taking this example of 2, 3, 1, 2, 0, 4. Suppose I reached from 2 to 3 or 2 to 1. From 2 I can reach either 3 or either 1. Suppose if I reached 1. Okay. Again I have to reach from 1 to 2. Again from 2 I can reach to either 0 or either 4. If I reach it to 0, so this is a dead end. So again I have to backtrack to 2 and again I have to traverse back from 2 to 4. So this is the backtracking. If you clearly see, 2 can be either going in direction of 3 or direction of 1. Again 1 will approach 2 and 2 can go to 0 or 4. So here if I went to 0, it is a dead end. So again I have to backtrack from 0 to 2. Again I have to travel from 2 to 4. So using this backtracking, we have to use recursion and the time complexity will be 2 power n. Because there are 2 power n ways to jump from first to last index. And space complexity is O of n. Because recursion requires additional memory to maintain the stack. Since the time and space complexity of our first approach is more, let us see how we can reduce the time complexity and space complexity using our approach 2, which is nothing but greedy approach. So let's discuss about this approach. Let us take our first example given in the problem, that is 2, 3, 1, 1, 4. So we will be maintaining a position called last good position. We will be traversing from last to first. First we will be maintaining the last array position as last good position. We will be traversing back to last minus 1 position. So here we will check if it can reach this last good position or not. Since 1 can be reaching this 4, we will be making this as last good position. Again we will traverse back from position 3 to position 2. Again from position 2 we can traverse back to position 3. So this position 2 will become now last good position. Again we will traverse back from 1 to 3. Now 3 can very well reach to 1 or index 2. So this will become our last good position. So again we will traverse back to one more position. That is, we will be reaching index 0. Now we will check whether 2 can reach 3 or not. So now 2 can reach this last good position. So this will be our last good position. Finally we will check whether the 0th index is last good position or not. If the last good position is 0th index, then we will be returning true. If last good position is not 0, then we will be returning false. So this is our greedy algorithm approach. So let us discuss the algorithm. So here, as mentioned previously, we are maintaining last good position is equal to n-1, where n is the size of array. So next we will be traversing from n-1 to 0 using for loop, and we will be checking if the position plus whatever the number in the array is greater than or equal to last good position. If it is greater than or equal to the last good position, then we will be modifying this last good position is equal to I. Again we will be returning last good position is equal to 0. Suppose we will be using the same example 2, 3, 1, 1, 4. First the position will be 4. Okay, so we are checking from n-1 to 0. So this condition will be like, now the I is here. Okay, so ith position is 0, 1, 2, 3. 3 plus AR of I 1 is greater than or equal to 4. Since it is true, now last good position will be 1. Again 1 position is 2 plus 1 greater than or equal to 3. So it is true. Again the position will be updated. So in this way we will be traversing until 2. So we will be returning if last good position is equal to 0 or not. Here, since we are traversing only one time, the time complexity is O of n and the space complexity is O of 1. So let us code through the solution of this problem. Here we are taking last good position is equal to, so we will be taking length of nums minus 1 for I in, so we will be also requiring x in reversed of list of enumerate nums. If I plus nums of I greater than or equal to last good position, we will be updating our last good position. After this for loop ends, we will be checking if last good position is equal to 0 or not. So let's click on run code. So now let's click on submit. So it is accepted. So that's it for this video guys. If you like this video, please click on like button and don't forget to subscribe. Thanks for watching till the end. Have a nice day.